Hey everyone, this is a new topic and we're going to be doing mathematical induction. This is a topic that I've been asked a lot about to explain, and it's one that I did have trouble with. This will mainly be for people who want to learn this, and also high school kids who are doing higher level maths and need this for tests, as it can be pretty tricky. But if you get the concept, it can be easy points. This will be a series of videos. This one will be more, there will be an example in it, but I'll also give all my tips and what you should be looking out for. But you'll see with the other examples, there's like 4 or 5 questions they can ask. They all divert from approximately those 4 questions, but they'll be seen in the 4 examples. This is the first example, and let's just start off by asking what is mathematical induction. Basically, it's just mathematical proof. It's a rigorous proof, and it does prove stuff. It's a proof of a proposition. And one thing to remember, though, is it doesn't work for every single identity that you might find in math. It only works when the numbers you're finding is found in a sequence or series, or there's some sequential element to it. A good example is a real world analogy of dominoes. So dominoes are in a line, and if you knock the first one over, then you know that the next one will fall over, and that each following domino will also fall over. Mathematical induction follows the same principle, that if you know the first one works, and then that every step after that works, they all will work. Yeah, this might still be a bit confusing, but let's just bear with me here. It should get clear. There are 2 steps to mathematical induction: the basic step and the inductive step. The basic step, it's easy. That's not a problem. The inductive step is where people seem to struggle, and we'll go through both of these steps. Just keep in mind that it's the inductive step you'd be slightly wary of. Okay, so this is an example of a proposition that could be given. 1 plus 2 plus ... plus n is equal to n plus 1 over 2. It's true for all positive natural numbers. Okay. So this is a proposition they can give, and we need to show that this is true. Prove it mathematically, rigorously. How do we do this? Mathematical induction, obviously. Okay, so we start off with the basic step. We have Pn, that's the proposition. This is the proposition over here. And the basic step is the lowest possible thing you can have. In this case, is all positive natural integers. So n equals 1 is the smallest one. So we need to show that the proposition is true for n equals 1. Now keep in mind that in some other propositions that they give, they may have other restrictions. For example, this proposition may be true only for n is greater than or equal to 3, for instance. So just keep that in mind, because if that's the case, then you'd have to use 3 as your starting number. It could also be n is less than or equal to 3. You still have to use 3, but then you have to go down instead of up. So just keep that in mind. In this case, we just substitute 1. In all cases, actually, just substitute the lowest number. In this case, it's 1. 1 times 1 plus 1 over 2, which is, of course, 1. So the proposition is true for n equals 1. Now, the inductive step. Again, I used to struggle with induction, and a tip that's really helped me is in mathematical induction in general, you have to look for the substitution with the proposition you are given. Now, this may still sound slightly confusing, but it should all become clear. It's just, you have to keep this in mind. It's extremely important. Look for the substitution. So let's see what I mean by that. Oh, sorry. One thing. Before we continue, we have to assume that the proposition is true for n is equal to some other random variable. We cannot assume it's true for n because that's what we're trying to prove. So we have to say if n is something else, k for example, we are assuming that this is true. This is extremely important, especially in tests, because if you don't write this, you lose points. So you have to assume it's true for another variable. You can't assume for n because that's what we're trying to prove. So assume that this is true, and we have to show that the next term, the proposition is true for the next term as well. And of course, the next term will just be k plus 1. In all cases, it will be k plus 1 because they normally just give you integers. So we have to show it's true for k plus 1. So we have to show, in other words, 1 plus 2 plus dot plus k plus 1, which is the next term, is equal to k plus 1 plus 1 over 2. This is just the next term. If you see here, it's just instead of k plus 1, just substitute k plus 1. So that's, if the proposition is true, that should be true. So if the proposition is true, this here, this should be true. We have to show that this is true. How do we do this? Well, we first start off with this. 1 plus 2 plus dot dot plus k plus 1 equals something. Now let's think it back. I said, remember to substitute. What do we substitute here? Well, we know that we've already assumed that, no, that's really bad. We've already assumed that this is this, right? That's what we assumed to be true. So we can just substitute this for this, okay? Because we've assumed it to be true. So we substitute it, and then once you've substituted, again, we're looking at the substitution. Substitute common denominator, and then it's just pure algebra from there on. K squared plus 3k plus 2, k plus 1 is k plus 2, and then you get this, which is exactly what we're looking for. Let's just check. Yes, here it is. This is what we're looking for, and that's what we got. Great. Done. That's all we need to do. You have to, again, remember though, to state a conclusion. As proposition is true for k plus 1, it is true for all k, and therefore it is true for all n. You have to state that. Yet remember though that this is not a universal conclusion. Some students, they tend to just write this at the end of everything. Remember, there are other restrictions on there, and you have to stick to those restrictions. If they normally say in the beginning, they normally give you the restriction, and you can just use that for the conclusion. So that shouldn't be too much of a problem. Also, one more thing is, if you just write the conclusion and don't do the inductive step, you won't get any points. Okay, so that's it. I'm just going to leave you with some tips I have of induction in tests. First off, always write formally in mathematical language, mathematical lingo. So don't write casually like, oh, this is kind of true for this and this and this. No, you got to write it. Proposition Pn is true for all. You can use the for all sign. If you guys don't know what that is, it looks something like that. Use the for all sign, use the natural number sign. Try and write as mathematically as you can, because of course, know what you're writing. Don't just start writing anything, but try and write as mathematically as you can, because that'll get you the points. Then of course, remember, always, I've lost so many points on this, and so many students have as well. Always remember to assume the statement is true for n is equal to k. And of course, always state the conclusion. Again, this is another place where students miss a lot of points. You will lose marks if you do not follow these rules. But yeah, I'll have a few more examples coming up, and hope you enjoyed this. See you later. First you were a thief, you stole my heart, and I, your willing victim.